My name is Amit, and I'm the founder CEO of GMAC Intelligence. And I welcome you all to this session on the fundamentals of training AML models for vision applications. A quick introduction. So GMAC is an AIML consulting company, and we help other companies build vision and generative AI applications all on edge. All right. As a quick show of hands, like how many of you have trained AIML models before? Cool. And how many of you thought it was magic? The fact that it works after a few epochs of training. Cool. So what I'm going to try and do is, demystify some of that. And the talk is roughly divided into, three parts. First, we'll go over some high-level concepts about training. Then we'll delve into some of the engineering math which makes a training feasible and possible. And then finally, we'll look at some of the practical aspects and caveats of training and deploying models. All right, so I think most of you are probably familiar with the vision AI task on the slide, right? These kind of range from image classification to object detection to segmentation to caption generation. And so what is common across all these tasks is that the input is always a visual input or an image. And the output kind of depends upon the task at hand, right? So in case of classification, the task is to generate a label, which kind of describes what is in the image, right? Whether it's an airplane or tiger or whatever. In case of object detection, the task is to go a level deeper, and within that image, identify an ROI or a region of interest, right, where exactly that object lies, which is kind of indicated using this bounding box around the tiger. And in case of segmentation, you kind of go even level deeper at a pixel level. And you say, whether this pixel belongs to a particular class or not. And then a cluster of those pixels kind of stand out as a segment, like what you see there, right? And in case of text generation, you analyze all the pixels, and you also want to come up with like a line of text describing really what's happening in that image. And so what is making all these vision AI tasks feasible and possible on the edge is what is called or known as a deep convolutional neural network. And so these are characterized by 5 to 1,000 layers, as you can see in this particular model here. At the input, there's an image, and at the output, you can see like there's a probability of probability distribution over the possible labels. And if you have a very high probability for a class, then it means that image contains that object, right? In this case, the dog has a high probability. And so what's really peculiar about deep CNN is that they have the ability to learn the parameters directly from data. So previously, what used to happen is people used to hand code a lot of these features and program them manually. But with deep CNNs, you can actually learn them directly from data using learning algorithms. And what do we mean by learning parameters, right? What are these parameters? So as you can see, in a CNN, you have like a convolutional layer, which has parameters like the kernel parameters or biases. In case of a fully connected layer, you have weights and biases. And so you're actually learning these parameters essentially when you go through the training process.